Practicing with derivatives, in example one, we have a product of two functions and we have an embedded function, so we're going to need to have chain rule. So I have my products of this term and this term here, and I have the embedded 3x squared plus 4 inside the 1/2 exponent. So when I differentiate this then, I'm going to differentiate the first part of this using my product rule. So I'm going to differentiate 1/2, and then I'm going to end up with power of negative 1/2. Okay, so there's my derivative of that first part. Now the inside remains unchanged, but because there is an embedded function, this is where I need to apply the chain rule. So the derivative of 3x squared is going to be 6x. And so this represents, all of this represents the first part of the product rule. And then I'm going to multiply by cosine of x. So that's the first part of the product rule, plus I'm now going to leave the first part undifferentiated. So it's just going to be 1/2 3x squared plus 4. Nothing happens there, but now I differentiate cos, and cos becomes negative sine x. Okay, so at this point I can then, group this together the best I can. There aren't really many like terms here, so there's not much I can do. I could maybe put this all under one denominator, so maybe I'll do that. So I'm going to express this as, I'm going to multiply everything by power 1/2 on top and bottom. So I'm going to be doing this. It's going to look like this: 3x squared plus 4 to the 1/2, 3x squared plus 4 to the 1/2 on top and bottom. Okay, so multiplying the top and bottom of that, we can simplify some of these expressions here. So in fact, I'm going to have a 2 here, and so put that 2 in the denominator. So I'm going to end up with 3x squared plus 4 times 6x cosine x, plus, this is going to multiply out. Oops, sorry, this is going to cancel out. I'm going to lose that 1/2 power exponent and the divide by 2 there. Then I'm going to end up with plus. This becomes 3. The 1/2 powers cancel. There are going to make it 1 whole power, so I get 3x squared plus 4 times negative sine x. So I'm going to do minus over here, minus, and then my sine x factor here. Okay, and then I need to make sure I include that extra 2 that I multiplied with as well. In the denominator, it's going to be 2 and then square root of 3x squared plus 4. Okay, so the colored part there is the derivative. The black part just represents a simplification. It looks like there are no common factors that I can simplify out. Maybe there's an extra 2 in there that I can cancel out, but I'm just going to leave it like that. For this one here, it's much the same. We're going to differentiate the first part, so we're going to differentiate e to the root x. Okay, well, the derivative of e just remains e, but because I have a root x, we need to differentiate that root x to 1 over 2 root x. Okay, that represents the derivative of the red. I'm going to then start applying my product rule, so that's the derivative of the first times the second, plus, this becomes e to the root x. We don't touch that, and then we differentiate the sign into cos x. Okay, and again, there's not much I can do here. There's a common factor of e to the root x, maybe that'll take out. Okay, and then what's left over is going to be sine x over 2 root x plus cos x. For example 3, we have the quotient rule and an embedded function of root x. So when I apply the derivative of this, I'm going to differentiate the tan first. So I get secant squared. But because that secant square, the tan has an embedded root x, I need to differentiate the inside and get 1 over 2 root x. That all represents the first part of that derivative. I need to multiply by e to the x, and then minus, this is tan root x. It's the first part of that expression, or the numerator undifferentiated, times the derivative of the denominator, which is e to the x. And in the denominator here, I end up with e to the x squared, or e to the 2x. Okay, so there's a common factor of e to the x that cancels out. So I'm going to just leave this as secant squared root x over 2 root x minus tan root x. And that's all over e to the x, since one of those x's in the denominator cancels out with e to the x. One of the easy x's in the denominator cancels out with that common factor of e to the x in the numerator.